Hi, this is a video about Dalton's law of partial pressure. So John Dalton is the same person that came up with the atomic theory like in the 1800s. He when he was studying gases, and what he found is that if you look kind of in this diagram here, if you have one gas that has a pressure of, let's say 1 atm, and then another gas with the pressure of 1 atm. Then when you add the gases together and you have a mixture of gases, the pressure would then just be 2 atm. So the pressure of each gas can be just added together. So you can see the Dalton's law can be written then as the total pressure is going to equal the pressure of each of the gases, however many there are, summed together. So there's this equation too. This equation is derived from the ideal gas law. I'm not going to show you that right now, but I think it kind of makes sense that the number of moles of any particular gas, and it doesn't matter what the identity of the gas is directly proportional then to the pressure of that gas. And the total pressure of the mixture of gases is going to be directly proportional to the number of moles total in the mixture. So I'm just going to show you a calculation, and there's just some pointers I have down here. Just that if you are given grams of the gases, you would want to convert to moles. Once you have the moles of the gas, you would then be able to calculate the total moles of the mixture. And also, sometimes you're given the partial pressures, and then if you have them all of the gases in the mixture, you can calculate the total pressure. And then there is some questions where at the very end they're asking you for the mass of the gases in the mixture. If that happens, you would want to calculate the moles of each gas and then convert to grams using molar mass. So here's a problem that we're going to solve together. So this is a mixture of 3 different gases. So one of them is hydrogen. We also have chlorine, and then we have methane. And then they're also telling us to find the partial pressure of each of the gases, but the total pressure is 2.8 atmospheres. So you can see, based on what I told you in the previous slide, that these grams would want to be converted to moles. This one's already in mole, and then we'll be able to figure out the total moles. And then we can use that equation that I had showed you previously. So the first thing, like I said, if we take our grams and convert to moles, so I have 2.2 moles of hydrogen, 0.22 moles of chlorine, and I was already given the moles of methane. So with that, I can calculate the total moles. So the second step then is they're asking you for the partial pressure of each gas. So they're asking you for how much pressure is just the hydrogen exerting, or how much is just the chlorine exerting, or how much is the methane exerting. So we're going to use this equation. So I know the moles of hydrogen I can plug in here. The total moles we calculated, the total pressure is given in the question, and then I'm going to calculate the pressure then P1, which would be the partial pressure of whatever gas, but in this case hydrogen. So then I can just do algebra. I cross multiply and solve. This is my x, and I get 1 atm pressure just for the hydrogen. And then similarly, I can do this for the chlorine. So I take my moles of chlorine over my total moles. I'm going to calculate the partial pressure of just the chlorine in the mixture over the total pressure of the mixture. And then similarly for my methane, so I have my 3.6 moles were given in the question over the total moles in the mixture. I can solve for the pressure of just the methane. And this is the total pressure of the mixture of gases. So we just solved the problem. So here is another type of problem with Dalton's law of partial pressure. In this question, we're given the pressures of each of the gases in the mixture, and you can see that they're given in millimeters of mercury, just another pressure unit. They don't always have to be in ATM. They would have to all be in the same pressure unit. So what we're doing here is the first thing, or the first step, would be to calculate the total pressure. So if I calculate the total pressure, I am just going to add those together, and that's why they would have to be in the same unit. So if one happened to be in like atmospheres, you would have to convert, you know, them all to atmosphere, or convert the one into from atmosphere to millimeters of mercury. So the total pressure of the mixture of gases is 773 millimeters of mercury. And then in the question down here, they also tell us the total number of moles of gas. And then they want to find the total mass of the mixture. So ultimately, what we're going to have to do here is we are going to have to, if I look at each of my gases, I know the total moles, I know the pressure of just that gas, in this case carbon dioxide, and I know the total pressure. So I can solve for, this would be my X, the moles of carbon dioxide. So when I get my moles of carbon dioxide at the end, because they're asking me for the mass of the mixture, I'm just going to convert that to grams. So they're asking for the mass of the mixture, so that is why I'm really going to have to solve for the moles of each of the substances in the mixture. So I'm going to solve for moles of water, moles of carbon dioxide, and moles of methane, moles of chlorine. You know, using just algebra here, because we know the total pressure is 773, the pressure of each of the gases, the partial pressure of the gas, and then we know the total moles. So once I get the moles of water, then I'm going to use molar mass to convert to grams of water. Once I know the moles of methane, then I'm going to use molar mass of methane to get to grams of methane. And similarly, once I get the moles of chlorine, I'm going to use the molar mass of chlorine. Notice it's diatomic, and then that'll give me the grams. So just to finish the problem, then you are just going to sum together all of these masses to give you the total mass of the mixture, which is about 353 grams. I hope that helps as you complete the worksheet on Dalton's law of partial pressure.